Hi, fourth graders. Today we're going to continue our lesson on remainders and try to figure out the answer to this question: what does the remainder stand for in a division problem? Yesterday you spent some time working on rounding up to find the answer. When a division problem is turned into a world problem, a real world problem, the meaning of the remainder can change. And it can actually change a lot of different ways. There are 4 different ways to interpret a remainder. Today we're going to introduce the second way that remainders are introduced. So today's question is what are 2 ways mathematicians can interpret remainders? One of the ways is that we can round up. I'm going to just type that in there, which we learned yesterday. We get a quotient, but it has a remainder. There's no such thing as 2 remainder for boats. So we have to say, well, actually that would really mean 3 boats, because you've got 2 full boats and then these 4 people who don't get to go. And, in the question, sometimes they have to go. They get to go because the person who wrote the question says so. The other way today that we're going to introduce how to interpret remainders is to actually use the remainder. Use the remainder. So these are the 2 that we're going to work with today. Okay? All right. Okay. So yesterday we looked at this problem. Mrs. Steenberg bakes 39 cupcakes, 1 for each student in 4th grade, and a container holds 5 cupcakes. How many containers will Mrs. Steenberg need if she wants to bring all 39 cupcakes to school? We solved this problem. 39 divided by 5. We took 39 cup. Stop it. 39 cupcakes. Here we go. Yes. And 5 cupcakes per container. That's where we got our dividend and our divisor. And then we came up with a quotient of 7 with a remainder of 3. And the 3 is the 3 cupcakes that did not make it into a container. The 7 is the containers. We know that at least 7 containers were needed, but in order to make sure that every cupcake gets brought to school, we actually needed to bump it up to 8, right? Okay, so we spent some time on that yesterday. I'm not going to spend a lot of time on it now, but just a quick review. And then you solve some problems a lot like that. And you were asked to come up with some of your own situations or scenarios. The first one today I want to show you as an example was written by Athena. And this was really great. So I'm going to use it today in our lesson. Athena said, my family and I, my whole family, she wanted to stress that, went on vacation. We have 35 people in all. I like the way she said that. 35 people in all. And some have offered to drive. All right, very well written. Everyone in our family has a car that can fit 4 people at a time. Okay, we're getting closer to some division problem. How many vehicles, here's our question, this is our how many vehicles would be needed to bring all of our family to our designated location? This is very fancy. Okay, so what am I going to do? Well, before I even worry about the remainder interpretation, I'm just going to divide, okay? So I'm going to say, all right, 35 divided by 4. And if Athena did this right in terms of coming up with a really good example that would need to be rounded, she would have a remainder, right? And she will, because 4 does not go evenly into 35. In fact, 4, I'm going to say 4 times 7 is 28. I start there because I know that one. It gets me kind of close to 35. What's 4 times 8? Well, that's 32. I'm getting closer. I don't think I can get another 4 in there because that would give me 4 times 9, and that's 32 plus 4 is 36. So I'm going with 8. Okay? So 8 is my quotient, but I'm not quite done. I'm going to now, actually I'm gonna take this out of here just to have some more room. Bear with me, thank you. Oh, yeah, okay. 4 times 8 is 32. Subtract, and we get a remainder of 3. What? 3 what, Athena? 3 what is our remainder? Well, these are 3 people. And those might be Athena and her 2 brothers. And they're definitely going to the designated location. So we are going to need another car. We have 8 vehicles already. We know we need 8. But guess what? Since we have a remainder of people, we really need 9. Okay? So the answer to Athena's awesome question is that her family of 35 will need 9 vehicles. Awesome. I like it. 9 times 4 people in a car is 36. That means we'll have an extra seat. Maybe somebody has a dog. Okay? Cool. Nice job, Athena. Let's look at another one. Here's another one that I saw that I liked. Emmett did this one here, okay? Jeffrey wants to bake cookies for his class. I love cookies. He can fit 8 on a sheet. And there are 30 kids in the class. All right, we got some numbers. How many sheets of cookies will he need to make sure he has enough? Well, how many what? How many sheets? My answer is going to be blank sheets. Okay, that I know I need to know that. So I'm going to leave that there just so I remember. I don't want to forget that I need to make sure I know what I'm actually labeling this problem. I know what I'm talking about. So 30 divided by 8. Okay, cool. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. That's too high, so I'm going with 3. I did that one in my head. 3 times 8 is 24. 30 minus 24 is 6. My answer is 3, remainder 6. But I can't put that as an answer to this question, because if I tell you to go into the kitchen and get me 3 remainder 6 cookie sheets, what are you're going to be like, what? Miss Nelson, have you lost your mind? What does 3 remainder 6 cookie sheets look like? It would be like 3 cookie sheets and then do I have to cut one into pieces? Well, maybe, but not in this case. So guess what? We're moving on up to 4 cookie sheets because 3 is not quite enough. All right, Emmett, nicely done. I thought that was a really good problem. And I chose it because it gave us a nice example of numbers that we know how to divide and that show us a great way to round up to our proper answer. And these are times when you really will use this. These are examples of times when you really will need to use this math in real life. I've done that twice now. 2 for 2, I've drawn that line when I try to slide up. Zayden. So Zayden had a great one too, and I like this problem because it has to do with kids playing. And it's a little different, but it still fit the bill. So here we go. Zayden says, there's a party with 27 kids, and only 5 are allowed in the bounce house at a time. Those of you who don't like to read, you have to read word problems. But when you read the word problems, after you read them, just find the numbers. Circle those numbers, okay? Now, you might get thrown a curveball someday, and somebody might write you a word problem that says, there's a party at 6 Maple Street, and that will really throw you off. And that's on purpose. This is there to confuse you so that you really are reading. Because this 6 has nothing to do with math, the math that we're doing. Okay, just a little aside, because I'm here to help. All right, let's start over. There's a party with 27 kids, and only 5 are allowed in the bounce house at a time. Bounce house? What? How many times will it take for them all to have a turn? Awesome. Awesome question. Because I'm going to have to have an extra time so that every kid gets a chance. 5 goes into 27 5 times. Come on. 5 times 5 is 25. We know this. 5 remainder 2. That means that 5 rounds of bounce house sessions are going to happen. We're going to have 25 kids who are like, that was awesome. Where are my shoes? And then 2 kids are going to be like, but I didn't get a turn. So guess what? They had to go last, but they get the whole thing to themselves. These 2 guys right here, these 2 kids, maybe it's Zayden and Zach. They waited till the end because they knew that they would go last, but they would have the whole thing to themselves, which means the answer to this question is, how many times? Well, the bounce house is going to be filled with kids 6 times. 5 full, and then 1 more. So that rounds up to 6 times. Zayden, this is a great problem. Thank you very much for that. I really like that one. And 3rd time's a charm, because I remembered. All right, sometimes the remainder tells us we'll need 1 more than our quotient. This is when we round up. And that's what we just did, okay? Sometimes the remainder is the answer. Okay. Today we're going to look at that a little bit. We're not going to round. We're going to look at the actual remainder as the answer, because that's what the question's really asking. Evan wrote this problem. I really liked it, so I decided to use it here. And it says, Evan and Gavin have 5 logs, and they each need equal amounts of logs. How many logs does the teacher take? So, this is a pretty straightforward question, right? There's 5 logs. It's kind of like the cars with Liam and Gabe, right? There's 5 logs. Oh, thank you, Evan, for giving me something that I can just draw like that. Aren't you happy that those aren't cars? All right, well, I am. All right, so let's do this. Evan is going to get 2 logs. He's going to have to carry those 2 logs. And Gavin, here's your 2. And then we get this one in the middle. And I'm going to just use that. And I'm going to take that one middle one. And this is an example of a time when the answer to the question is the remainder. Because the question is asking, how many logs does the teacher take? Well, I know that Evan is taking 2. And I know that Gavin is taking 2. Because they have to have equal amounts, because Evan said so. And the only way that can happen is if they each have 1 or they each have 2, right? There's 1 more. This is an odd number. 5's an odd number. So that 1 more is for the teacher. So Miss Russ is going to carry this log. I don't know where they're going. I don't know what they're doing with the logs, but this totally works. And this is a great example of a time when you will use the remainder is the answer. The remainder 1, the answer to 5 divided by 2 kids, 5 logs divided by 2 kids is 2, remainder 1. And the answer to the question is the remainder. It's not always true that that's the way this works, but today in this example, it is. Nice. Evan, thank you. I got another one from Sebastian. Here's another great one. Here we go. All right, Sebastian says, I have $20 and the video games I want cost $7. All right, so he's got $20 and the video games that he wants cost $7. He's already going to tell us right up front that he can get 2 games and get a cheap game with his change. Okay, so 2 games at 7 is 7. 7 plus 7 is 14. And then we know he can buy another one with his change. So what will his change be? Okay, so if 7 plus 7 is 14, as a division problem, this looks like 20 divided by $7. $20 divided by $7 is 2, with a remainder of 6. He almost had enough. Man, if he had one more dollar, he could have gotten 3 of them, but he didn't. So we can't round this up because you can't make a dollar appear when there isn't one. It's not like kids on a boat. This is not enough money. So we need to take the remainder as our answer. What will the change be? $6. And he's going to use that change to buy a cheaper game. Nice. Sebastian, good job budgeting and really nice word problem. I like it. Okay. Oh, man. All right. Okay. For some reason, I just pictured Andrea laughing at me. All right. Today, when you practice in your Google Doc, you're going to decide which remainders tell you that you should round your quotient up, like yesterday, and which remainders are your actual answer. A little tricky, because you're going to have to really look at the problem and see what it's asking. Do what I did, circle the numbers and underline the part of the problem that is actually the question. You know, do that. Do yourself a favor there. You can highlight it on the Google Doc if you want to, or you can rewrite it out on your whiteboard, whatever works for you. Just remember that you do still need to be doing this division with each problem. And that means writing it out in long division style. Okay? Have fun, and I'll see you later.